Well, hello, and welcome back to Mrs. Cox's classroom. And today what we're going to be doing is we're still working on the beginning of the year review for 8th graders. This is the beginning of the year review, day 4. And this one is probably the first one that's really hard, ones that the kids hated, and will continue to remind themselves how much they hated it. It's all looking at area of circles, triangles, trapezoids, squares, and all your basic shapes. And so they know some of them pretty well. They still don't know some of them. And so again, it's that refresher. So a lot of notes on the formulas, again, reminding them if they get these formulas in their notebook at the beginning of the year. We're at the beginning of the notebook. They're all close together. It's easier to find them all whenever they have to work on that. And hopefully eventually, my hope is that they have those formulas memorized by the time they get themselves to high school. So we'll take a look at what those actual skills were in Get More Math. And so we're in my work, and we'll go to the 8th grade and the beginning of the year. And this is beginning of the year review, day 4. And again, it's given radius, determine circumference, determine area of a circle, determine area or circumference of a circle, determine areas of rectangles and parallelograms, and determine areas of triangles and trapezoids. So I'll assign that. Notice these check marks here said I have assigned it to these classes. That's because I have. They were for those classes last year. And this is for that summer school class that I just created to make these videos for you. And now that's been assigned, so I'll go to my student account. Now, as my student logs on, we'll see that we are at the beginning of the year review, day 4. And so here's the one working with the circumference of a circle. And these are skill codes 1062043 and 1062042. The next one is dealing with the exact measurement, and trying to get them to understand the exact measurement means we don't have to use an approximation for pi. And so the math is actually simpler. And so hopefully they'll start to realize that when they see 0.36 pi meters squared, that they're not having to calculate pi. It makes it a lot easier. This is skill code 1062850. The next one is find the area of this shape. This is skill code 1062019. Hopefully by now this is absolutely simple. The next one is a skill finding the area of, these were triangles or trapezoids. So this question right now is asking for a trapezoid. The next one may ask for a triangle. The skill code is 1062021. And then again, this is looking for circumference of a pi, 1062042. So again, it's just looking at that geometry and making sure that they have a good solid idea, and reminds them at the beginning of the year to get all of those formulas in the beginning of their notebook together so that it's easy to find whenever they work on those for the rest of the school year. And so now you'll see me actually teaching the lesson. Well, good morning. So now we're at the beginning of the year review, day 4, and we're going to be taking a lot of notes. So you're going to need to make sure to get your workbook out and your notebook, because we're going to be taking a lot of notes that I'm going to expect you to have ready in class on Monday. Okay, so I'm going to go ahead and share my screen. And this is what the beginning of the review, day 4, looks like. We're going to start right here with some formulas. So these are the formulas of parallelograms, trapezoids, triangles, and circles. You should know these by heart. So you're going to make sure that you need to know these. Okay, so parallelograms they include squares and rectangles. And so we're going to go straight to that. So the formula for perimeter of a parallelogram would be 2 times side 1 plus 2 times side 2. If you're measuring the perimeter, you're just wanting to know the outside edge, you're going to add 2 of these and 2 of these together, okay? And that gives you your perimeter. For the area, we need the base times the height, okay? And so the height is always going to be the distance between one base and the other base, okay? So it's a perpendicular line that connects one base to the other base. You'll see it's a 90-degree angle. That's why we can't use this one, because it's not a 90-degree angle here. So there is the height right here, and it's base times height. Of course, on a square or a rectangle, we would see this is a 90-degree angle right here, and so this becomes the base. This does become the height because it is a perpendicular line that measures the distance from one base to the other. Just like this is a perpendicular line that measures the distance from one base to the other, and that's the height. For a triangle, well, when you think about a triangle, what we want you to kind of remember is that if we cut a rectangle in half, we end up with a triangle. And so we're going to take those formulas for the area, and it's just base times height divided by 2. And for the perimeter, it's just side 1. Okay, so for the perimeter of a triangle, it's going to be side 1 plus side 2 plus side 3. You're just going to add up all of your sides. And then that's the formula for perimeter. When we get to trapezoids, so for trapezoids, trapezoids have one set of parallel lines. And they don't have the other set are not parallel because the bases are not the same measure, okay? So we call this one just base 1. It doesn't matter which one you label as base 1 and base 2. I just usually take the larger one as base 1, just out of habit. Probably most of the time, because most of the time when you see trapezoids, we usually see the longer base on the bottom. So that's probably why I do it. The height is still the same as how you would find the height in a parallelogram. It's going to be a perpendicular line that measures the distance from one base to the other. Okay, so it's that exact same idea of understanding how we get that measurement. It is the distance between one base and the other in a perpendicular line. Okay, so that's the height right there. So in order to kind of understand that, I did this last year, I'll do it again. If I just took this parallelogram, take the picture of this right here and send it right here, and then I'll take it and I'm just going to turn it around, and then I'm just going to lay it right here. And I see that when I do so, I mean, I know my lines aren't straight, but what I see is I see a parallelogram, okay? And so I'm going to use that information to kind of help me figure out the area. So I know that when I flip this around, this was base 2 over here. The way we figured out is the exact same way we figured out the area of parallelogram. So it's going to be base times height. Well, my base here is both bases, so it's going to be base 1 plus base 2 times the height, right? Because that height doesn't change. It's that measure from one base to the other, perpendicular line. But since this is 2 trapezoids, we're going to have to divide it by 2 in order to get back to just one trapezoid. And so that's the formula for a trapezoid, the area of a trapezoid. For the perimeter, it's just side 1 plus side 2 plus side 3 plus side 4. All of the sides could have different measures, so you're going to have to add each one separate. Don't assume that any of them are the same. So it's just side 1 plus side 2 plus side 3 plus side 4, okay? And then, of course, the next one is circles. So I have a circle right here. In order to remember how to deal with circles, you have to remember all the different terminology. So I'll go ahead and write those in. A line that starts at one side of a circle, goes through the center to the other side, is called a diameter. A line going from the center to the edge is called the radius. Okay, and so to find circumference, there's 2 formulas, okay? So circumference can be pi times diameter or 2 pi r, because we know that 2r is 1 diameter, right? So this would be a radius right here, and then this would be a radius right here. So there's 2 of them. So it's either 2 pi r, so 2r times pi, or just pi d. And then the way I use it is if they give me diameter, I use pi d. If they give me radius, I use 2 pi r. And then the formula for the area is pi r squared. So hopefully you had these memorized from last year. You need to make sure you do memorize these. We just basically consider these the most basic of all shapes, and learning their formulas is important. We'll be adding more formulas this year, but for today's review, we're just starting right here, okay? We're going to go back into the textbook and see what we have there. And so now we're just going to start using the information that we have to actually start solving these. So let me go ahead and get some of these over there. Okay, so we are going to solve the odd problems in the workbook, and then in class we'll solve the even ones, and then you'll start on your assignment. A circle's diameter is 19 inches. What is the circle's circumference? So the biggest trick here, I think, is kids start using the wrong formula. So just remember, we're talking about circumference. The formula we want is C equals, and then there's 2 different ones. There's pi d or 2 pi r. And again, the way I choose is I look to see if they give me radius or they give me diameter. And what they're actually giving me is diameter. So since they're giving me diameter, I'm going to use this formula right here. And I just replace it. They want us to use 3.14 for pi, and it's so it's 3.14, so that's pi times d, which is 19. And then I just do the math. 3.14 times 19 is 6, carry the 3, 9, 10, 11, 12, and then 27, 28, and then 4, 3, and then I'm going to add these. So I'm going to get 6, 6, 9, 5, and then I have to move my decimal 2 places, and then it says round to the nearest tenth. So is it going to be 59.6 or 59.7? So 59.66 rounds up to 59.7, so it's 59.7 inches. And remember, units of measure count, okay? All right, the next one. Pocahontas is watering her yard with a sprinkler. She places the sprinkler 5.9 yards away from the edge of her house so that the water does not hit her house while the sprinkler is rotating. How much of her yard will be covered? So the first thing I do is I just go ahead and I draw a picture, okay? So here's the side of her house right here, right? And then here is the sprinkler that she has in her yard. And she wants it to spray, and it's going to spray in a circular pattern. So, and she doesn't want it to hit her house because, you know, that will start to ruin the siding on her house. And if anybody's ever had that happen, you know, you don't want that to happen. So it's going to go in a circular pattern, but she doesn't want it to hit her house. And she places it 5.9 yards away from the edge of her house. So I know that this measure right here is 5.9 yards. So I'm going to go ahead and write that in my picture. And again, whenever you draw a picture, it just helps you understand the math a lot better, all right? And then how much of her yard will be covered in terms of pi? Well, in terms of pi means we do not have to actually multiply by 3.14. We get to leave pi in our answer. And so we just use the formula for area, and area is pi r squared. And so then it just becomes the area is pi, which we get to leave alone, times 5.9 times 5.9. And then we just do that math. So we'll just do 5.9 times 5.9, and we get 81. And then 45 plus 8 is 53. And then we get 45, carry the 4. 25 plus 4 is 29. And then 1, 8, 4, 3. And then we move our decimal over 2 places. And then we look to see which one is closest to this. 34.81. Well, it's not this. It's not this, but it is this. So the answer would be C. Okay. The next one says a circle's radius is 23 inches. So I'm not even going to do anything else till I draw my picture. So I'm going to go ahead and I'm going to draw a picture. And it says the radius. Well, the radius I know is the measure from the center of the circle out. So I'm going to draw my radius. And they said that is 23 inches. And before I even get myself messed up with anything else in the equation, I'm going to draw my picture, and now it matches this right here, okay? So they match. What is the circle's area? So again, I'm going to start with the formula for area, and it's equal to pi r squared, okay? So then I'm just going to substitute. I get area is equal to pi, which they want us to use 3.14, times 23 times 23. Now, when you have numbers this large, I don't mind you using a calculator, okay? So you'll just go ahead and you'll use that calculator just like I'm going to, because what I'm teaching you is the formula. I don't care right now if you can multiply 23 times 23. There's going to be times in your life where you have to prove that. Right now, I want you to prove that you know the formula and that you can solve this. So it's 23 times 3.14, and that is, the area is approximately, because once we use the approximation for pi, we use approximation, and that's 166.1.06. And then they say they want you to round it to the nearest tenth. So it becomes 1661.1. And then it was inches, and we multiplied inches times inches, so our answer is inches squared. Okay. Let's try the next one. Find the area to the nearest tenth. So in order to understand what this is, you have to know what it is, okay? So I see that I have these two lines right here that are parallel, and their measure is 11 feet. And I have these two right here, they're also parallel, and their measure is 9 feet. And then we have this measure right here from this base to this base, and that's 6 feet. So this is a parallelogram because a parallelogram has two sets of parallel lines, okay? So, so there's the first set, there's the second set, so I know it's a parallelogram, and I know the formula for a parallelogram. So the formula for the area of a parallelogram is base times height. So the height is the measure of it's a perpendicular line that measures the distance from one base to the other. So this one right here is the height. And so that helps us figure out that the base, we're measuring from this one to this one. So this is the base. So just being able to understand that that's how you figure out which one's the height, which one's the base. I start with my height first because my height measures the distance between the two bases. And so that tells me that. So now I know that the base is 11 and the height is 6. And so I multiply those together and I get 66. And then of course I multiplied feet times feet. So I end up with feet squared. And then the last one is number 9, find the area. So again, you have to know what this shape is. And I see that I have a set of parallel lines, but the other sides are not parallel. So this is a trapezoid, okay? So a trapezoid has one set of parallel lines. We have to use a formula for a trapezoid. And again, the formula for the area of a trapezoid is base 1 plus base 2 times the height divided by 2. And then we just start substituting. The height is right here. It is that measure of the distance. It's a perpendicular line that measures the distance between the bases. So here's one base, here's the other one, okay? It doesn't matter which one you make base 1 or base 2 because it all comes together in the end. All right, so I have 18 plus 10 times 16 divided by 2, okay? So it doesn't matter how you actually do this. For me, I think I'm going to go ahead and divide by 2 first. And so then I'm just going to do 100, sorry, that's going to be 28 times 8, which is going to be a lot. That should have been a plus, sorry. So that's going to be a lot easier than a double digit because now this is like super easy. So the area is equal to 8 times 8 is 64. Carry the 6. 8 times 2 is 16, 17, 18, 19, 20, 21, 22. And then it was centimeters, and we did centimeters times centimeters. So we end up with centimeters squared. So there is the lesson for the beginning of the year, day 4. And I'll see you in class. Okay? All right, you guys. See you later. Bye. And that is the end of this lesson in Mrs. Cox's classroom. If you are enjoying my videos, please like and subscribe. Thank you.